Bismillahirrahmanirrahim. Welcome back, dear students. I hope all of you are fine and enjoying good health. Students, this is our 23rd lecture, and in today's lecture, we are going to discuss chapter number 8, that is about thermal properties of matter. In our previous lecture, we discussed about temperature, heat, internal energy, and about specific heat capacity and heat capacity of a substance. And we also discussed that what is the difference between specific heat capacity and the heat capacity of a substance. And the topics that we are going to cover in our today's lecture are change of state of matter. We will discuss that how can we change matter from one state to another state, and then we will discuss that what is meant by latent heat of fusion, and we will also discuss that what is the difference between latent heat of fusion and the melting point of a substance. And similarly, after that we will discuss about the latent heat of vaporization of a substance. And then at the end of the lecture we will discuss about evaporation, that how evaporation takes place. By the end of this lecture, students should be able to understand that how is matter changed from one state to another state. Students should also be able to understand that what is meant by heat, latent heat of fusion and latent heat of vaporization. And students should also be able to understand that what is evaporation and how is evaporation different from boiling. So the very first term that we are going to discuss in our today's lecture is change of state of matter. Students, matter can be changed from one state to another. For such a change to occur, thermal energy is added or removed from a substance. Now, in order to understand the concept of change of state of matter, look at this picture. Students, take a beaker and place it over a stand, as you can see here in this picture. Put small pieces of ice in the beaker and suspend a thermometer in the beaker to measure the temperature of the ice. This is the thermometer that is used to measure the temperature of the ice. Now students, place a burner under the beaker. The ice will start melting. The temperature of the mixture containing ice and water will not increase above 0 degree centigrade until all of the ice melts and we get water at 0 degree centigrade. If this water at 0 degree centigrade is further heated, its temperature will begin to increase above 0 degree centigrade. Now students, look at this graph. This graph is of temperature and time, showing change of state of ice into water and steam. Students, look at the portion AB of this graph. On this portion of the curve, the temperature of ice increases from minus 30 degree centigrade to 0 degree centigrade. Now students, look at the portion BC of this graph. When the temperature of ice reaches 0 degree centigrade, the ice water mixture remains at this temperature until all the ice melts. And the curve CD, as you can see here in this picture, this is the CD curve of this graph. The temperature of substance gradually increases from 0 degree centigrade to 100 degree centigrade, and the amount of energy so added is used up in increasing the temperature of water. Now students, look at the portion DE of this graph. At 100 degree centigrade, water begins to boil and changes into steam. The temperature remains 100 degree centigrade until all the water changes into steam. Students, now I hope you will have a clear idea that how one form of matter is changed into other form. Students, when a matter is changed from one state to another state, then either the energy is added or the energy is removed from a substance. So we can say that thermal energy plays very important role in change of state of matter. Now students, the last topic that we are going to discuss in our today's lecture is the evaporation. Students, take some water in a dish. The water in the dish will disappear after some time. It is because the molecules of water are in constant motion and possesses kinetic energy. Fast moving molecules escape out from the surface of water and goes into the atmosphere. This is called evaporation. Thus we can say that evaporation is the changing of liquid into vapors, that is gaseous state, from the surface of the liquid without heating it. Students, unlike boiling, evaporation takes place at all temperatures but only from the surface of a liquid. The process of boiling takes place at a certain fixed temperature, which is the boiling point of that liquid. At boiling point, a liquid is changing into vapors not only from the surface but also within the liquid. These vapors come out of the boiling liquid as bubbles which break down, reaching the surface. Students, evaporation plays an important role in our daily life. Wet clothes dry up rapidly when spread. Evaporation causes cooling. Why? During evaporation, fast-moving molecules escape out from the surface of the liquid. Molecules that have lower kinetic energies are left behind. This lowers the average kinetic energy of the liquid molecules and the temperature of the liquid, since temperature of a substance depends on the average kinetic energy of its molecules. So thus we can say that evaporation causes cooling. Students, evaporation takes place at all temperature from the surface of a liquid. The rate of evaporation is affected by various factors. So these are the few factors that affect the rate of evaporation. The very first factor that we are going to discuss is surface area. Students, why water evaporates faster when spread over large area? Large is the surface area of a liquid. Greater number of molecules has the chance to escape from its surface. So we can say that evaporation is directly proportional to the surface area of the liquid. And the next factor that we are going to discuss is wind. Students, wind blowing over the surface of a liquid sweeps away the liquid molecules that have just escaped out. This increases the chance for more liquid molecules to escape out. Now the last factor that we are going to discuss is temperature. Students, why wet clothes dry up more quickly in summer than in winter? At higher temperature, more molecules of a liquid are moving with high velocities. Thus, more molecules escape from its surface. Thus, evaporation is faster at high temperature than at lower temperature. So, students, this is all about today's lecture. Students, when a substance is changed from a solid to liquid state by adding heat, the process is called melting or fusion. The temperature at which a solid starts melting is called its fusion point or melting point. When the process is reversed, when a liquid is cooled, it changes into solid state. The temperature at which a substance changes from liquid to solid state is called its freezing point. Students, different substances have different melting points. However, the freezing point of a substance is the same as its melting point. So from this we can say that heat energy required to change unit mass of a substance from solid to liquid state at its melting point without change in its temperature is called its latent heat of fusion, and it is denoted by HF, and the formula that is used to calculate the latent heat of fusion is HF equals to delta QF divided by mass of the substance. Here delta QF is the heat energy required to change unit mass of substance from solid to liquid state at its melting point, and it can be calculated as delta QF equals to mHF, where m is the mass of the substance and HF is the latent heat of fusion of that substance. Students, in order to calculate the latent heat of fusion of a substance, let us consider an experiment. Take a beaker and place it over a stand as you can see here in this picture. Put small pieces of ice in the beaker and suspend a thermometer in the beaker to measure the temperature. This is the thermometer that is used to measure the temperature. Place a burner under the beaker. The ice will start melting. The temperature of the mixture containing ice and water will not increase above 0 degree centigrade until all the ice melts. Note the time which the ice takes to melt completely into water at 0 degree centigrade. Now students, continue heating the water at 0 degree centigrade in the beaker. Its temperature will begin to increase. Note the time which the water in the beaker takes to reach its boiling point at 100 degree centigrade from 0 degree centigrade. Now students, the next topic that we are going to discuss is latent heat of vaporization. Students, when heat is given to a liquid at its boiling point, its temperature remains constant. The heat energy given to a liquid at its boiling point is used up in changing its state from liquid to gas without any increase in its temperature. Therefore, students, the quantity of heat that changes unit mass of a liquid completely into gas at its boiling point without any change in its temperature is called its latent heat of vaporization, and it is denoted by HV. And the formula that is used to calculate latent heat of vaporization is HV equals to delta QV divided by M. Here students, HV is the latent heat of vaporization, M is the mass of the substance, and delta QV is the quantity of heat that changes unit mass of a liquid completely into gas at its boiling point. And the formula that is used to calculate the value of delta QV is delta QV equals to mHV. Students, when water is heated, it boils at 100 degree centigrade under standard pressure. Its temperature remains 100 degree centigrade until it is changed completely into steam. Its latent heat of vaporization is 2.26 into 10 raised to power 6 joule per kilogram. That is, 1 kilogram of water requires 2.26 into 10 raised to power 6 joule heat to change it completely into gas or steam at its boiling point. Now students, this was all about today's lecture. Now I am going to summarize today's lecture in just 1 to 2 minutes. So students, we discussed about latent heat of fusion and latent heat of vaporization in our today's lecture. And we discussed that the heat energy that is required to change unit mass of a substance from solid to liquid state at its melting point without any change in its temperature is called its latent heat of fusion. And the amount of heat that changes unit mass of a liquid completely into gas at its boiling point without any change in its temperature is called its latent heat of vaporization. And then we discussed that how matter changes from one state to another state. And then at the end of this lecture we discussed about evaporation, and we discussed that evaporation is the changing of a liquid into vapors gaseous state from the surface of the liquid without heating it. And we also discussed that unlike boiling, evaporation takes place at all temperatures but only from the surface of the liquid. And then we discussed the rate of evaporation is affected by various factors such as temperature, surface area, wind, and nature of the liquid. We discussed that the rate of evaporation is directly proportional to the temperature of the substance and the surface area of the substance, which means that greater will be the temperature and surface area, greater will be the rate of evaporation. Now students, this is your homework. The first question is learn the differences between latent heat of fusion and latent heat of vaporization. And second question is define evaporation. Also write on what factors it depends. Now students, this was all about today's lecture. I hope now you will have a clear idea about change of state of matter and evaporation. But still, if you have any query, please note down that I will answer all of your questions in Zoom session while using whiteboard. Thank you so much and Allah Hafiz.